তোমার আসছো কেন ভাই? ক্লাস হচ্ছে। Good afternoon, everyone. Welcome to the sixth class of reagents in organic synthesis. In this class, we are going to discuss about some boron-based reagents, aluminum-based reagents, sulfur-based reagents, and phosphine-based reagents. So first, I'm going to discuss about boron-based reagents. So in this boron-based reagent, we will discuss about allyl diisophenol camphyl boron, which is famously known as Brown's reagents. So which is famously known as Brown's reagents. It mostly used as chiral allylations for aldehyde and ketone. So in these cases, this kind of allyl boron compound in presence of aldehyde selectively gives cis product if the geometry is Z, or the trans allyl or the E allyl in presence of aldehyde give the trans or E product selectively. This is a Z product. So this is the product which are we are getting. So this can be explained. So if we used plus or beta Brown's reagents or plus reagents, we will get product 3 as a major product and 4 is a minor product. So the if we use plus or the camphyl group, which is beta pyridine group, which is this one. So if this is in beta, so we'll get the beta product as a major product, and if it is alpha, which is this one, so we'll get uh, alpha product, in this case beta, in this case alpha product, which is this one 4 as a major product. So in both these cases, as we if we use Z alkene, we get the Z product, or if we use E alkene, we will get the E product. So this is the major and minor product. So this can be explained by this transition step. So in these cases, this finding group is beta orientation. So this is the allyl or protonyl group, which is in Z orientation. Now, when we use aldehyde, so this will go like this way, this will go and attack with the aldehyde. So as this alpha phase are blocked, so the the beta phase are blocked, so the reactions occur from the alpha phase, and thus we are getting this OH as a beta phase, and this is Z, as we are using Z allyl group. In case of E, so this is the E1, this hydrogen and this hydrogen are in trans. In this case, also if we use E, we will get anti as product as a major product. But as we are using uh, plus or beta pinene group, so the attacks happen from the alpha phase, and the product we are getting the beta alcohol as a major product. This is the beta alcohol product. In this case, also we are getting beta alcohol product as we are using the plus or beta Brown's reagents or pinene. If we will use alpha pinene, so in these cases, as the alpha phase are blocked, So the electrophile or aldehyde has to come from the attack has to happen from the beta phase, and then alcohol will go to the alpha phase. So in these cases, if we use alpha, then we will get alpha alcohol. If we use syn, then we will get the syn product. If we will anti or trans allyl group, so then we will get the trans product. It is also in case of beta or the minus reagent, minus brown reagent. So now we will discuss about some example of this IPC2 boryl application in natural product synthesis. So in these cases, we are getting allyl product with the after attack of this alcohol, and after subsequent step, they are producing the natural product of centrolobin. In this case, also this minus IPC2 B allyl has used. So in this case, also the allylation happen, and we are getting this chiral product. So this is in alpha as we are using minus product. So these are the general application for the synthesis of natural product. Now I'm going to discuss about aluminum based reagent. So in this aluminum based reagents, I will discuss about carboalumination of alkynes by using zirconium catalyst. So what happened in presence of zirconium, aluminum, this and any kind of alkyne such as this one R1, R2 in presence of cyclopentyl zirconium chloride, aluminum, trimethyl aluminum. What happened? First, aluminum and zirconium undergo transmetallation. So it forms this dimer, and in this dimer, the methyl group transferred to the zirconium and chloride will leave. So this will give this product. Now what happened? In presence of any kind of alkyne which has electronically rich, so this will first coordinate with the zirconium center and liberate one chloride ion. So now this chloride ion, liberated chloride ion, attack on the aluminum center, and from this deuterionic species. Now from this deuterionic species, there is a possibility of migration of this methyl, which is uh, come from the aluminum center. So this will attack on the R1 side, and this will go and this will neutralize like this way. After that, there is a possibility of transmetallation. So now there is a possibility of transmetallation. So this will react with the aluminum center and giving this syn addition product. Now this vinyl aluminate in presence of such as any kind of electrophile undergo a electrophile exchange reaction. So now if we treat it with this compound as butyl lithium, so the butyl is positive. Now there is a possibility butyl is react here and aluminum center. So it will go like this way. Aluminum minus methyl, butyl, lithium plus. So now this is will neutralize and transmetallation happen. There will be change. This aluminum is will change with lithium. So that is called transmetallation. Transmetallation. So this will go give like this compound lithium. So this is positively charged, this is negatively. Now this in presence of any kind of electrophile such as methyl iodide, benzaldehyde can be trapped. So that negative charge attack on the methyl iodide and liberate this iodide, or it will attack on the aldehyde center, giving subsequent transformation. So this will give this methyl one or this alcohol. So if this aluminium has some coordinating agent or the alkyl has some coordinating agent, in these cases this alcohol. So if this is alcohol is there, the aluminium will coordinate with the alcohol. Now further, when this aluminium, in these cases we are observing cis product, right? So this is giving cis product R1 and R2 in the same places, whatever this is the coming from the aluminium group, methyl, or this is the electrophile. So in these cases, both R1 R2 in the cis form, and this attack happened from the cis orientation, that coordination. So, but if there is a coordinating group which can coordinate with the aluminium, then there is a possibility of isomerization. This double bond will isomerize, and this aluminium will coordinate with this oxygen. So in these cases, this R group can change its orientation, so from cis to trans. So in these cases, by trapping with any kind of electrophile, we will get the anti-product. So if there is a coordinating agent, we will get the anti-product. If there is a no coordinating agent, in presence of aluminium, carboalumination of alkynes happen and we will get the cis product. So now I am going to discuss about some sulfur containing reagents. So first I will discuss about classical Julia olefination reaction. So any alkyl phenyl sulfone in presence of base proton, this is the acidic proton, alpha proton. So any kind of base such as NaOMe. So this will Na plus, OMe minus. So this will abstract and it is from this negative charge. Now in presence of aldehyde, this negative charge will attack and from this compound. Now it will trap this compound by some acyl chloride. So here I am using Cl. So this will go this compound. Now further, in presence of base NaOMe, it will give an sodium amalgam in methanol or ethanol, give the alkene. So this will give alkene. So from alkyl sulfone, alkyl sulfone, alkyl sulfone, we will get alkene. So this reaction is called as Julia olefination reaction. What is the mechanism in this reaction? And what is the roles of sodium amalgam? So first sodium amalgam in presence of methanol from sodium methoxide. So this will abstract this proton, and it will, as this is a leaving group, so after abstraction this proton, this will leave and generate this vinyl sulfide. So now as sodium has a single electron transfer reagent, so it will transfer one of the single electron to the sulfone, and this bond will radically clip and give this radical, this vinyl radical. So this is vinyl radical, vinyl radicals. Now in presence of another sodium, so it will transfer single electron here and give this negative charge vinyl anion. Now this vinyl anion, as you are using methanol, ethanol as a solvent, so this will abstract proton from the methanol, ethanol solvent and giving this E alkene. So if we, this is the classical Julia olefination reaction, and In these cases, we are getting olefin from sulfone. Now there is a term modified Julia olefination reaction. In these cases, we use this reagent benzothiazole reagent, that is BT. So now same as it is proton abstract by base and attack with the aldehyde and giving this reagent minus whatever the sodium methoxide or ethyl potassium methoxide, whatever we are using, this will give O minus Na plus. Now there is a possibility of Smiles reagent. So what happened in there? This negative charge attack here and this will go. This will give this compound. Yes, yes, double one two R R H O. So this will give this one. Now this negative charge come and back and this bond will break and this will give like this one. So what form? I'm cleaning this one. This will give this one. There is sulfur, nitrogen, double bond. Yes, double bond O minus R1 R. Now this will go, and this will. So now after this, we are getting this alkene plus. I'm taking this one. This area is congested. So we are getting this product R double one R H plus present sulfur. There is a double one. Yes. So after sulfur elimination, we will get the metal salt, benzothiazole, and this alkene. So this is the modified Julia elimination reaction. This happened after the sulfur elimination and Smile rearrangement. So this elimination is called Miles rearrangement. So this is the modified Julia elimination. So now I am going to discuss about Korsakovsky reagent. So there is a two possibility of Korsakovsky reagent. One is the sulfide. This is sulfide. Trimethyl sulfide. This is sulfoxide. So here this is the S double one O is there, and this is S plus trimethyl sulfide, trimethyl sulfoxide. So dimethyl sulfoxonium methylide, this is called, and after treatment with sodium hydride or in any strong base, so this protein will abstract and negative charge will come. So this is called dimethyl sulfoxoniamide, and this is dimethyl sulfoniamide. Right. So this is more stable as the sulfur oxygen double bond is there. So it will go like this way. and stabilize itself. So due to the sulfur oxygen bond, this sulfoxide, dimethyl sulfoxide halide is stable, but in these cases, this is not stabilized. So this is stabilized halide, this is unstabilized halide or strong halide. As this is stabilized halide, because this negative charge is moving of the sulfur vacant d orbital. So for this is soft. This due to this stabilization, this is hard. So if we use any kind of ketone or enone, so as this is soft, as with if we use ketone, it will directly react with the ketone and giving this epoxide. I am coming to the mechanism. But if we use this enone, as this is soft and this position is also soft, so there is a possibility of soft hard interaction. So, so for this soft hard interaction, this methylite react in the 1,4 fashion and giving cyclopropane here. But in these cases, as it is a very strong or hard nucleophile, so it directly attack to the 1,2 in this case also, and in this case also there is a possibility of 1,2 addition. No 1,4 addition is happening. So here 1,4 1,4 addition or enone, but in these cases directly 1,2 addition or enone because of the soft hard interaction. As this methylide is the sulfoxonia methylide is soft and 1,4 position is soft, so it will give the cyclopropane, but in both the cases it will give epoxide for sulfonia methylide as it is a hard and no stabilization of this negative charge. So what is the mechanism? So in both the cases sulfide or sulfoxide, if we use only aldehyde or ketone, it will react with the ketone center or aldehyde center, giving this um, O minus S plus. So now this O minus reactant S plus will remove, and after removal of sulfide will give the epoxide. Whatever for the cyclopropanation reaction, as this is soft, so it will react in the 1,4 fashion. Uh, Michael addition happen and giving this one, and the negative charge will come back and it will react here, and after elimination of DMSO, dimethyl sulfoxide, will giving the cyclopropane here. So now I am going to discuss about Kore-Winter olefilation reaction. So in these cases, diol or dithiol in presence of this thioimidazole, diimidazole thiocomplex and phosphide, giving this alkene. So what is the mechanism here? So first, if we using dialcohol such as R1, R2, R3, R, this one. So now first this will attack and imidazole will leave, and this will attack and imidazole will leave. So first this will give this thiocarbonate. Thiocarbonate. Now this thiocarbonate in the presence of phosphide giving alkene, and whatever the carbon dioxide or carbon disulfide and phosphine sulfur complex. So the mechanism is, so after formation of this thiocarbonate, phosphide react with the sulfur center and giving this, and now if this bond will break, it is from this carbene, so it can be go through the carbene mechanism. Now phosphide again react with the carbene and giving this ylide, phosphone ylide. Now after the this is negatively charged, so the, after the elimination of this we will getting this alkyl, sorry. So there is a possibility of another mechanism, anionic pathway. So now here after elimination of this sulfur phosphate complex, so it will give this carbene, but if we will attack directly with this phosphine center, it will give this way. And now phosphide attack on the sulfur, this will go and this will attack. So uh, this intermediate, so now this intermediate undergo rearrangement and giving this alkene. Now I'm going to discuss about dimethyl sodium. So this is the DMSO, negatively charged DMSO sodium complex. So if we treated dimethyl sodium with any kind of ester, such as this one, so it will react with this carbonyl center and OMe liberate. This will give this one. So now if we treat with aluminium or amalgam, so what happens in these cases? We will get this acetonitrile. What happened? Aluminium or sodium can transfer a single electron to the sulfur. Single electron will go and this after getting this one. It will come like this way. Sorry. One. And this will giving this one. RCO. So this will extract proton from the solvent and giving this product 3. Now if we treat it with this compound with bases such as potassium dioxide butazide, this is acidic, this proton, so it will extract and react with this bromo compound and giving RCO S double one C double one C double one to OM. So if we heat this reaction mixture, what happen? So I'm just so if we heat this reaction mixture, what happens? So now what happen here? Sulfur is positively charged, oxygen is negatively charged, so this will abstract this one, this will go and this will go, so we'll get product 4. So now if with this if we add acid, so what happen? So this is paratoluene sulfonic acid. This S is positive, O minus. So in presence of acid, it will extract H plus. The O minus will extract H plus. So it will give R C double one to S plus OH. So now this proton will go and water will eliminate. This will give RCO SME plus. So this allyl will form. So now in presence of any kind of nucleophile, this allyl will trap and giving product 5. Now I'm going to discuss about heating reaction. So this is come under the phosphine chemistry. So any kind of halide, alkyl halide, such as CH3Br, any kind of alkyl halide in presence of phosphine, nucleophilic attack of this phosphine happen and this halide group will leave and giving this phosphonium salt. Now this phosphonium salt in presence of base abstract this proton and from this phosphorus halide. Now this phosphorus halide in presence of aldehyde and ketone undergo olefination reaction and give this olefin. So there is a possibility of two. There are two possibilities: stabilized phosphine and unstabilized halide. So if this R2 and R1 is alkyl or aryl, this will be unstabilized. But if this is a electron withdrawal group such as ester, cyano, these are electron withdrawing groups, so that's why it is stabilized. So the halide will call as stabilized halide. So what is the mechanism in this reaction? And this halide will attack on the carbonyl center and giving two possibility. One is cis orientation and one is trans orientation. So if this R3 and phosphine are or R3 or R2 are cis orientation, in these cases this R3 and R2 are trans orientation. In these trans cases there is a possibility of steady-kindness, but there is a no possibility. So that's why this is the stabilized intermediate. So now after forming this one, so this O minus react with the phosphine and form this cis also phosphonate intermediate, and after elimination of phosphine oxide giving this alkene. So Z alkene is the major product. So as this is the stabilized intermediate and this is a unstabilized intermediate giving the minor product. So this in presence of unstabilized phosphine, unstabilized. So if we use phosphide or phosphanoacetate as a stabilized phosphine, so the negative charge is stabilized on the phosphine center. That's why it's called stabilized phosphine. So with this stabilized phosphine, we will get as a major product. E alkene as a major product. This is called Warner emulsion Marshall olefination reaction. So same mechanism followed. This proton was abstract by base and the negative charge will form, and this negative charge will trapped by any kind of aldehyde. So after the phosphide elimination, we'll get these two transition states, syn and anti-transition state possibilities there. So we'll get the E isomer as a major product. Then I'm going to discuss about Mitsunobu reaction. So in these cases, any kind of primary or secondary alcohol react with phosphine, react with phosphine and date or diisopropyl azide, this kind of NN. This R will be CO2 or isopropyl or amine, giving or any influence of nucleophile, giving the nucleophile attack product, but opposite orientation. So inversion of uh, the stereochemistry happen in case of Mitsunobu reaction. So if we treated this alcohol in presence of acid as a nucleophile, so we'll get this ester. If we use this which and one alcohol as a nucleophile, we'll get this ether, or if we use thiol as a nucleophile, we'll get sulfide, or if we use amine as a nucleophile, we'll get the alkyl or alkyl amine, or if we use azide, we'll get the azide connected product. So what is the mechanism of this reaction? So phosphine react with the NN double bond and giving this deuterionic product. Now this deuterionic product abstract proton from the nucleophile which we are going to add. So giving this product and nucleophile. So in the step 3, the alcohol react with the phosphine and neutralize the system. We will give this and this halide, phosphorus halide. So now as this nucleophile react here and phosphine oxide will liberate. So this will give the inversion of stereochemistry. So if it is in beta phase, the attack should be happen from the alpha phase. That's why we are getting this inversion of stereochemistry. So this reaction is very important reaction, Mitsunobu reaction. Next, I am going to discuss about Schrodinger reaction. So in this case also, any aryl azide will give amine, aryl amine in presence of phosphine. So what is the mechanism? So this is the azide. So if I write this way, so this is the resonating structure, forward N minus N plus triple bond. Now this azide in presence of phosphine react this way and this will neutralize this one. So giving this intermediate, this intermediate. Now this intermediate, this N minus undergo a reaction with this phosphine center and after elimination of nitrogen, we are getting this immunophosphorin and or azaelide. This azaelide will getting and this in presence of water. So we are getting this primary amine. So if we use ketone here, then we'll get the imine after the reaction of this ketone will react with this fluidic reaction happen here, azabatic happen, and after elimination we'll get this imine. If we react with this acid, then we'll get this amide after azabatic reaction. Now I'm going to discuss about some problem. So the first problem is to find out the product with appropriate deuterium level. So this is a Julia olefination reaction. So what happened? First sodium amalgam in presence of NaH2PO4 and CD3OD from sodium methoxide. So this will abstract as this proton is acidic. So this is abstract of this base and after U1CB this U1CB mechanism this OSC will remove and giving this PHH2CH2CH2. Yes, double one, two, double one. Now, in presence of sodium, so it will transfer single electron. This, this, and this. So this radical will form. This radical will form. Now this radical after reaction with another sodium forming this anion. Now this anion can be quenched by the CD3OD proton CD3O. This will react with this. So the deuterium level happen here. So the right answer, the- this one, option C is the right answer. So this is the Julia-Olivination reaction. So I'm cleaning this for the next question. So now this dim side sodium. So this is the dim side sodium. So this negative charge will react with this one. This will go. This will go and ethanol will remove. So this will give this one. 8 S C2S double one O. Now in presence of zinc, so single electron transfer happen. As zinc is a metal, so it's single electron here. Now this will give this radical. This will take one electron and give this negative charge. So this negative charge is quenched by the solvent or acetic acid reaction we are using. This will give this one RCO CH3. So the right answer is this one. The third question is methyl magnesium bromide with this phosphonoester. So MEI MgBr. So as this proton is acidic, so methyl abstract this proton and from this negative charge. So this is Warner-Wittig reaction, Warner-Emerson-Wadsworth reaction, Warner-Wadsworth-Emerson reaction. So K double one two. This negative charge will come. Now this is trapped by the aldehyde. With minus R1 CO2. So now the Wittig reaction happen. This will go like this. So and new give this olefin. So as this is stabilized Wittig, it will give the stabilized Wittig, it will give the EI product. So this is the right product due to the stabilized stabilized phosphonoester. So here what happened in the question code. So the inside sodium they have used plus 1 to minus sodium plus. So here this reaction happened like this way. It will react with the ketone center and after elimination of ethanol, giving this product. So now They are using sodium methyl iodide they have used. So now this is the acidic proton. So sodium plus as a counter anion and water also have in the system. So it will generate sodium hydroxide. So that will act as a base and abstract this proton plus. So it will absorb this proton and giving this one. Now this is presence of methyl iodide. Yeah. So what happened is yeah. So methylation happen on that active position. Methyl. This proton is also there, so this is also methylated. And after treatment with zinc acetic acid, so it will form this negative zinc reactor and this will go and given this will accept proton and give this product. So this is the carboalumination of alkyl. So what happened in these cases? So first zirconium react with the alkyl and aluminium will transfer. First if I am writing plus AlMe3. So this will transfer and this will go leaving this Ke2 chloro methyl Me2Cl. Now further reaction and zirconium same mechanism will be this one same mechanism follow. So this will ultimately give this product. So methyl and aluminium will Me2. So the carboalumination happen here. Now this in presence of butyl lithium, the aluminum will react and giving this one. So now transmetallation happen with the this one like with the lithium and aluminum transmetallation happen and give this is give Li. So this is positively charged, this is negatively charged. It will react with the formaldehyde like that letter with the carbonation, we are leaving this alcohol. So what happened? So this is the right answer. So in these cases, isopropyl phosphonate acid ester and methyl phosphonate ester has been used. So in case of bulky substrate, we'll give the GEA as a E alkene as a major product after Wittig reaction, Warner, Holmesworth, and Emmons Wittig reaction, and with the less critically hindered, substituent will give the Z alkene as a major product. So for that, as this ester and this is the Z, in this cases, this and this is E. In this cases, this Z and this is cases E. So this and this not possible. So in this both that this Z and this is Z and this is OME is less bulky. Now in these two cases, this is E and this is Z. So this is also not possible. Y isopropanol is bulky, that's why you get the E isomer. So the correct answer is 2. And the structure, so as the aryl correlation happen, 6, 3, 3, double 1, 2, 8. So this will go and it will react here. So as this is Z, we'll get the Z product as a major product or syn product as a major product. So and this is the positively or beta timing has been used, so it will get attack happen from the alpha phase and then OH will come to the beta phase. So among this is the alpha, this is E, this is J, this is J, this is E. So both the E is not possible as we are using J allyl. Among these two, as we are using this positively or beta filing, so it will get the beta product. So this alpha product is not possible. What is the next question? The major product of X and Y. So what happening? This is the example of Robinson annulation. So the cyclopentanone will react with this. So this the acid will activate the carbonyl center and this pyridine, pyridine, nitrogen lone pair. Yeah, it will go like this way. This and plus Welch. Now, after elimination of water, it will give this one. Now, this is also neutralized. So, this will give this enamine. Now, this enamine in presence of alpha beta unsaturated ketone undergo a Michael reaction giving this iminium species. So you see, now this iminium in presence of acid and H plus form the ketone that now in presence of sodium hydroxide NaOH. So there is a possibility of alkyl reaction. So this proton will abstract by the base and react with the this center. So this will give OH, right? CH2, C the whole one. After elimination of water, abstraction of base, this will give this product. So this is the example of Robinson annulation reaction. Now, this Borodichovsky reagent has been used. So this is the sulfide, dimethyl sulfide halide. So as this is the unstabilized, unstabilized one, so it can't attack on the 1,4 fashion. So it will attack in the via 1,2 fashion. It directly attack on the ketone SME minus this plus. So this is react with the carbonyl center. Now it will react and dimethyl sulfide Me2S will remove from the system, giving this epoxide. So the right answer is this one, option B. So the next question is in Core winter definition, find out which points are incorrect. So what happened in Core winter definition? R1, the diol in presence of imidazole, thiol, imidazole thiolate compound, giving the alkene and phosphide. So first it react with this thiol compound and giving this thiocarbonate. So 1 to diol give alkene. This is the right cyclic thiocarbonate also from right. That intermediate undergo phosphorus reagent by anti-elimination give no this go through carbene mechanism. Reaction is also specific. So E isomer will get so this if we see the reaction. So this is a co-winter reaction. So in these cases we will get the specific stereospecific product. So the option are incorrect is the 3 and 4. What is the name of this reaction transfer? So Arbuzov reaction. So in Arbuzov reaction, what happened in Arbuzov reaction? Phosphide place of Rx will give phosphide R E double one O R O R. In apple reaction will what happen if this kind of alcohol is used in apple reaction? This under halide or CBr4 or any kind of iodine will get the halides product halide. So this is also inversion happen in apple reaction. Only in Mitsunobu reaction will get the inversion of stereochemistry. If we use water as a nucleophile here, so we'll get the inversion of stero. So the Mitsunobu reaction is the right answer. So these are the question which we have, and these are the topic. So I think this is clear for everyone. If you have any question, you can ask me. Okay, then if you have no question, then thank you for today.